The Lewis acid-base concept, proposed by Gilbert N. Lewis in 1923, is one of the most fundamental theories in chemistry. Unlike Arrhenius and Bronsted-Lowry theories, which focus on proton transfer, the Lewis concept is based on electron pairs, making it broader and more versatile. Definition of Lewis acids and bases according to Lewis. 1. A Lewis acid is an electron pair acceptor. 2. A Lewis base is an electron pair donor. This definition expands acid-base chemistry beyond just H and O ions, allowing it to apply to a wide range of chemical reactions. Examples of Lewis acids and bases. 1. Lewis acids, electron pair acceptors, are stated as follow metal ions such as ferric ion, Fe cubed, aluminium ion, Al cubed, and cuprous ion, Cu squared. Form coordination complexes molecules with incomplete octets as boron trifluoride and aluminium trichloride molecules with polar multiple bonds as carbon dioxide carbon D-oxide. Here carbon acts as a Lewis acid. 2. Examples of Lewis bases, electron pair donors, are ammonia, NH. It donates an electron pair to form complexes. Water, HO. It acts as a Lewis base in hydration reactions. Hydroxide ion, O. It can donate electron pairs in nucleophilic reactions. How Lewis acid-base reactions work in a Lewis acid-base reaction. A Lewis base donates an electron pair to a Lewis acid, forming a coordinate covalent bond. Example: ammonia and boron trifluoride is an example of Lewis acid-base concept. Ammonia donates its lone pair and act as Lewis base. Boron trifluoride accepts the electron pair and act as Lewis acid. 3. A new coordinate covalent bond forms between nitrogen and boron. Applications of the Lewis concept. The Lewis acid-base theory is crucial in 1. Coordination chemistry. Explains metal-ligand bonding in transition metals. Catalysis. Many catalysts like aluminium trichloride in Friedel-Crafts reactions act as Lewis acids. 3. Biochemistry. Enzymes use Lewis acid-base interactions to catalyze reactions. 4. Organic chemistry. Nucleophiles, Lewis bases, and electrophiles, Lewis acids, drive reactions. Comparison with other acid-base theories. Conclusion: the Lewis acid-base concept provides a broader understanding of chemical reactivity, especially in coordination chemistry, catalysis, and organic reactions. By focusing on electron pairs, this theory explains interactions that cannot be described by Arrhenius or Bronsted-Lowry definitions. Understanding Lewis acids and bases is essential for mastering advanced chemistry topics and their real-world applications. Right finger like, share, and subscribe for more chemistry insights. Microscope sparkles.